The next group that we have verified before is the set G containing the elements 0, 1, 2, 3, 4, 5, 6, and 7, or the Z sub 8, and it's actually a group under addition modulo 8. We also have verified and provided the equivalent subgroups of this group, and this time we are going to come up with a subgroup diagram with we will actually present all of those subgroups into one more formal diagram. So as mentioned, here are the groups, or I mean subgroups of this given group. We have the set containing, or the set G itself. We have the Z sub 8, or the set containing 0, 1, 2, 3, 4, 5, 6, and 7. This is actually the subgroup of the largest order. Okay, it's the group itself. Another subgroup that we have identified in one of the videos in this playlist, please try to review that, is actually the set containing the identity of this group. Okay, that's the subgroup of order 1. We have also verified another subgroup. It's actually the subgroup containing 0 and 4. Again, try to verify this in one of our videos. Please try to look into that as to the process of the identification. And actually, we still have one more subgroup here. It's actually the subgroup of order 4 containing 0, 2, 4, and 6. Yes, we have 4 subgroups for this given group. Again, a video was already provided for that. Now, for our subgroup diagram, we simply place our subgroups in a specific order, where the largest order is actually placed at the top and the least order is at the bottom. So we are to start with our set G, or Z sub 8, or other references will only write the set itself, but I'm just going to write all. Okay, this is actually at the topmost portion of our subgroup diagram or lattice diagram, and then at the bottommost portion is actually the subgroup with the least order. I'm talking about this because this is also actually a subgroup of order 1. We have here 0. Our next task is to place the two subgroups somewhere here, such that we actually come up with a certain order where the subgroups at the bottom are subsets of those at the top. Now, if I'm going to place the subgroup of order 2, I can place it here, 0 and 4. This is in no problem, because we can see that this is actually a subset of this, or the element 0 can be found here. Okay? And at the same time, since our last subgroup rather contains the same element of 0 and 4, so we can place it here, 0, 2, 4, and 6. In this specific order, we can say that this is a subset of this set or group. This is also a subset of this subgroup, and of course all of these are here, so this is also a subset of that. So we can actually write it in this order, because what we can see at the bottom are of course subgroups or subsets of what is at the top. To complete this subgroup diagram or lattice diagram, let us use lines to connect them. So basically we use something like that here and here. This means that they are actually a certain order and inclusivity, as we have again what is found at the bottom are actually subsets of what are found at the top. Some references use arrowheads for lattice diagram, but without those arrowheads, it's more formal based on one reference I have read, and this is actually what we call as Hasse diagram. It's a diagram without arrowheads, but basically this is still correct, and this is a subgroup or the lattice diagram of this given item. Thank you very much for watching.